Hello everyone, welcome to lab number 4. The name of this lab is the spectrum of atoms. We will study about the spectrum in this lab. What is spectrum? The spectrum is a set of electromagnetic waves. In this lab, we are interested only the waves that we can observe by eyes, which is light. Light has 7 colors, from red to violet. The wavelength of violet light is about 400 nanometers, and the wavelength of red light is about 700 nanometers. And what is the source of spectrums? Let's look at this example. If I have an iron box and I burn it by fire, the box will turn into red. And if I have an instrument that can collect the light that come out from the box and plot the graph between the wavelength of light in x-axis in the unit of nanometers and the intensity in y-axis. We have known that the light is red. That means the graph you got should skew right, like this. It is this graph that called spectrum. This kind of spectrum is called continuous spectrum. As you see that the graph is continuous, like this. However, there is another kind of spectrum that comes from this. If I have a gas of pure elements such as mercury and hydrogen, I put it in a tube and apply a high voltage to it, about 5000 volts. I do the same. I collect the light from this tube and plot the graph of the same kind. You will find that the graph you got is just a discrete line like this. This kind of spectrum is called light spectrum. And you will study this kind of spectrum in this lab. The next question is why the atom emits spectrum like this? The answer of this question is come from Bohr atomic model. Bohr told us that atom has positive charge, then as nucleus, and electron with its negative charge move around a specific orbit. The energy level of atoms can be explained by this equation. En equal minus 1 over 8 e to the 4 me over epsilon 0 square h square multiplied by 1 over n square, where n is integer 1, 2, 3, and so on. Thus, the energy level of atom is discrete, like the step upstairs. Okay, then when I apply electric energy at this, electron will absorb energies and it will jump to the higher level and it cannot stay there for a long time. Then it has to go back or decay to the lower level and emit the photons. We have learned this concept in Lab 3 already. We knew that the energy of the photons is hf, where f is frequency of photons. I use the relations C equal f lambda to change these equations into hc over lambda. This is the energy of emitted photons. Then we go back to these equations. I told you that atom has discrete energy level at this when atom make a transition. So you can calculate the energy difference of atom at this equation. Suppose atom make a transition from Ni to Nf. Delta E is as these equations. You just pull out the constant and the left parts minus together in parentheses. However, I know that the atom emits photon after it make a transition. This means that the energy of photon equal delta E of atom. So we can write this relation. E photon equal hc over lambda. Delta E is known from above. Substitute them. These are constant. H is Planck constant. C is velocity of light. I move this constant into the right hand side. I'm sorry. This have to be h to the 3's. This h and this h. Oh, sorry. You have to change h to h square. So we get h to the 3's because we move h here. C is also moved downwards here. All of these constants here are combined and call it R infinities or Rydberg constant after Mr. Rydberg invented this equation. So we can write this equation as this equation 1 over lambda equal R infinity multiplied by this parenthesis. If n can be only integers, delta 1 over n squared can be only some value. This is the same for lambda. This is the reason why light emitted from a atom has some specific wavelength, not the same case as iron box. In this lab, we will measure these R infinities. Okay, come back to consider this instrument. This instrument can measure intensity of light in its wavelength. It is called a grating. This instrument is very simple. It is just a transparent plastic sheet, but if we zoom in, we will find that it's a stripe pattern, a black stripes alternate with space. If I assume that the black line separated by distance d, that the distance d from data printed on a grating that I will show you later. It is split as 500 lines per 1 millimeters. That means in just 1 millimeters, there are 500 black lines in it. If you want to know the distance between lines, you can calculate at this. 500 lines has length of 1 millimeters. That is 10 to the minus 3 meters. So that one line has length of 10 to the minus 3 over 500, right? You can use a calculator or you can multiply by 1000 and divide by 1000. It is the same as you multiply by 1. This is calculated as 2 multiplied by 10 to the minus 6 meters or 2 micron. That we get d equal 2 micron. We will measure this distance in our lab. Okay, now let's look at the real setup of this lab. We have a mercury gas tube and we apply it with an electric energy so that it emits light. The light will go straight and pass through the grating, the same instrument as this instrument. We will find that 90% of light will go straight and fall at the center of the screen, but 5% of light will go to the right hand side and another 5% will go to the left hand side. This 5% of light will diffract and show a rainbow color. Violet light diffract in small angle, but red light diffract in a big angle. This side is the same. Violet is here and red is here. They are symmetry, you see? It's like your palm. If I compare this violet and this is red, if I compare with this graph. This wavelength is violet and this wavelength is red. This means that if you see these lines in graph, you will also see lines in this region. This side is the same, but it is opposite because it's symmetries. If I shoot one line, assume that it is a line of green color. Then draw a line like this. This line will make an angle, say the green with the central line. Okay, the equation that explains this behavior is this equation. D sine theta equal m lambda. D is the length between lines in the grating. Zeta is this angle. Lambda is the wavelength of light. M is the co-order of diffraction, which equal 1 in this case. From this equation, if you can measure the angle theta, and I tell you the wavelength lambda, you can calculate D, right? Or in the other hand, if you can measure theta, and I tell you the value of D, you can also calculate the lambda, okay? This is the equation that we use in the first and the second table in your report. After you know the value of lambda, use these equations. 1 over lambda equal I infinity multiplied by this parenthesis. If I tell you the value of NF and NI, you know lambda, so you can calculate I infinities. This is all of this lab. Okay, now we see the experiment, and this is the tube that I told you. This is the mercury tube, and this is the high voltage source. When I turn on the switch, the light will come out from this tube. This light is the mix of white and blue. Okay, this is the spectrum that we have to do the experiment in this lab. To do the experiment, I use state. The state has slit and a ruler here. Okay, and this is called grating. You will see that it's right 500 line per millimeter. Okay, you can use this number to calculate the value of D, or in the other hand, you can do the experiment to find this value. Okay, put this grating to this. Here can be moved. In this case, I put this grating at the length as long as possible, which is 25 centimeters. Okay, then I move the tube into this behind the state, and I align the state until the tube align with the slit. So the slit will align with the mark 0 of the ruler. Then, if we zoom in, we look through the grating. You will see that on the left hand side, you will see a line, three colors lines, a violet, a green, and a yellow line, right? Okay, this line align with the marks of the ruler, so you can read the position of them. And the right hand side is the same, so you can read the position of them. Okay, let's go back to the experiment. This is the mercury lamp. Light from the mercury will go through the grating. 5% of light will diffract to the right hand side. Another 5 go to the left. So we can observe 3 lines colors. Okay, violet, green, and yellow. Okay, I choose only one line. For example, a green line. This line make an angle theta to the central line. Okay, The equation that explains the behavior is d sine theta equal m lambda, m equal 1 in this case. Lambda is the wavelength of light, d is the length between line in the grating. Okay. For the first part of experiment, the table 1, it tells you the color of each spectrum and tell you the wavelength of them. And there are two columns. The first column is for right hand side, another one is for the left hand side, and asks you to measure XR and XL. For the position of spectrum, left it blank. The data of XR and XL I will give you in the link. What is XR and XL? XR is the distance between the center positioned to the line that we are interested in the right hand side. For XL, it's the same thing but for the left hand side. Because it's symmetries, XR should be equal XL. But in reality, they may be not equal. So we should use the average value of them. X bar equal XR plus XL over 2. Consider this triangle, this raised triangle. Okay. If I know this distance, which is XR, and if I know this distance, I call it L0. L0 is the distance between grating and the screen. Come back to the real setup. The distance between the grating and screen is 25 centimeters, right? So L0 is equal 25 centimeters. Consider again that red triangle. XR over XL. XR over XL has the relation to the angle theta, that is tan theta. But because I changed from XR to X bar, because we use the average value, so I can get the angle theta equal arctan of X bar over L0. After you know the angle theta from this equation, if I told you about lambda, you can calculate d. From this equation, d equal lambda, because m is already 1, over sine theta, where theta is come from the previous equation. This is the part 1 of the experiment. If I saw the table 1 in the report, it's up to you to measure XR and XL and calculate X bar. After X bar, it's up to you to calculate angle theta from arctan X bar over L0. This is L0. After that, you can use lambda to calculate d from this equation. Lambda over sine theta. So you get 3 value of d. Write down, average them to get the average value and put it here. D should be equal to 2 micron. When you do the calculation, be careful about the unit. This is the end of the first part. For part 2, We do the same thing as the part 1, but in this time we have to change the tube from the mercury tube to hydrogen tube. This is hydrogen tube. Insert it into the source. The hydrogen tube will give you a pink light like this. Do the same thing. Move it behind the slit. Aligning the slit with the tube. After aligning, you will see spectrum, 3 lines, with its violet, blue, and red. For table 2, you do the same thing, but in this time they not tell you about the lambda anymore. It's asked you to measure XR and XL and calculate X bar and theta. For this value, you know already from the previous table. You know the average value of D. Copy the average to this table. When you know D, you know theta, you can calculate lambda. Come back to the formula. You know that D sine theta equal M lambda. You know D, you know theta. So you can calculate lambda equal D sine theta. This is the part 2 for the table 2 in this experiment. So you know the lambda of 3 spectrum. Okay, this is all of the part 2. For the table 3, this table is tell you about the color of the spectrum and the wavelength of them, and this is the lambda from your experiment that you know from the table 2, this lambda. So you can copy these 3 values into this table. The next column is NF and NI, and the next one is R infinities. So if you remember, I have the formula of 1 over lambda equal R infinity multiplied with this parenthesis. Okay, so when you know lambda, you know NF and NI, so you can calculate R infinity for me. This is the table 3. So you get 3 values of R infinities. Average them and put it here. For this part, it's asked you to calculate percent error of your lambda. So you calculate from lambda theory minus lambda experiment over lambda theories. Take an absolute and multiply by 100. And this is the same, but calculate for R infinities. R infinity theory is in your lab manual. The next part is answer your questions and conclusions. That is all of this experiment. Thank you very much.